Hello, geometry students. Today we are going to talk a very quick lesson about volumes of pyramids and cones, and you're going to find out why it's quick in a second. So the volume of a cone or the volume of a pyramid can really boil down to one equation, and that equation is right here. It is 1/3 capital B times H. Well, isn't that just like the one we just did for prisms? The volume of a prism was the area of the base times the height. The volume of a cone, or if I scroll down, the volume of a pyramid is 1/3 the area of the base times the height. And that's it. If I wanted to, I could stop this video right here and say if you want the volume of a thing that looks like a prism but with a pointy top instead of a flat top, you just take the area of the base times the height and divide by 3. That's it. Now, let's get a little bit more specific, but I'm going to try not to overcomplicate things. So, pyramids and cones. Here's a bunch. This thing right here is a pentagonal pyramid. Why is it a pentagonal pyramid? Because it has a pentagon on the bottom and it comes to a point. This thing right here has a square on the bottom. That's a square pyramid. And then this thing in the middle has a round bottom, so we don't call it a circular pyramid, we just call it a cone. All right? Now, a cone has a circle at the bottom and comes to a point. You can have a right cone, which just goes straight up where the vertex is directly above the center of the bottom, or you can have what's called an oblique cone, which is a little bit slanty. Each of those have the same volume. It's 1/3 the area of the base times the height. Now, since the base of a cone is a circle, we've got to remember that the area of a circle is pi r squared. So a lot of times, instead of remembering that the volume of a cone is 1/3 BH, we think of it as 1/3 pi r squared H to make it a little bit easier. Now, what's a pyramid? A pyramid's just like a cone, but with a polygon on the bottom instead of a circle on the bottom. Okay? You have your base and you have your apex, or you can call it a vertex. I've seen it called both. All right. And the volume of a pyramid is 1/3 BH. And remember, when you see a capital B, that means the area of the base. Okay. What do you notice about the formulas on the same? They're the same. And they're 1/3 times the volume of a prism. Okay. So, new volume formulas. If you forget them, you can look them back up, but I think if we use them enough, it's going to stick in your brain. There is one page of examples for this. That's it. So let's get through that page. And you know what? I'm going to open up my calculator right now so that when I need it, it is available to me. So it says find the volume of the cone below in terms of pi and round it to the nearest tenth. All right, the volume of a cone. Let's write out the formula, 1/3 pi r squared h. So this volume would be 1/3 pi 21 squared times 42. Now, if I want that in terms of pi, I'm going to type everything except for the pi into the calculator. So I am going to type 1/3 times 21 squared times 42. And that's 6,174 pi millimeters cubed. So there's my volume in terms of pi. And if I want that volume to the nearest tenth, I will take that number, 6,174, and multiply it by pi. And it doesn't like that input argument is numeric. What is happening? 6,174 times pi. I don't know what it like. 19,396.2. 19,396.2. And that would still be cubic millimeters. Example 2, if the volume of a cone is 48 pi and the height of the cone is 27, find the diameter of the base of a cone. Well, let's just draw a cone, for fun. Here's my cone. I know that the volume is 48 pi. I know that the height is 27. They want me to find the diameter. Well, the volume of a cone is 1/3 pi r squared h. Well, let's see. Volume, I know what the volume is, so let's erase that v and write 48 pi. 1/3 pi. Do I know the radius? Nope, don't know that, so I'm going to leave that as an r. And I know the height is 27. They want me to find the diameter, but if I want the diameter, I could just find the radius and double it, right? So let's go with that. So if I want to solve this, the first thing I'm going to do is divide both sides by pi, which effectively cancels the pi's out. Then I'm going to multiply both sides by 3 because of that 1/3. So let's see, 3 times 48, that's 144, equals r squared times 27. So now let's divide by 27. Divided by 27. And that gives me a value of 16/3. Running out of room here. So 16/3 equals r squared. And then I'll square root that to get my radius. So let's see. The square root of the answer is 2.3094. And if that's my radius, my diameter is 2 times that. And it's 4.6. When in doubt, let's round to the nearest tenth. Our diameter is 4.6 centimeters. Now, what did we get out of that problem? Just that you can do with these problems what you could do with everything else, which is plug in what you know, solve for what you don't know. All right, find the volume of the square pyramid. Okay, well, when I have a square pyramid now and not a cone, my volume formula is 1/3 the area of the base times the height. Well, let's see. If this is a square, that's 12 by 12. So the area of the base would be 12 times 12. And our height is 6. 1/3 the area of the base times the height. Plug all that stuff into the calculator. 1/3 times 12 times 12 times 6, 288. And that would be cubic meters. All right, penultimate one here, 2 to go. Find the volume of the square pyramid here. Well, the volume is going to be the area of the base times the height times 1/3 because it's a pyramid and not a prism. So that's going to be 1/3 the area of the base. Well, that would be 8 times 8 times the height. Ooh, that 72 is in a different position than that 6, right? Or 7.2. My height should be in the middle. So what I really want is I want this thing. But they gave me this 7.2. Well, that's odd. Well, you know what I can do with it? Is I can draw a right triangle right there and say that if this square pyramid has a base length of 8, that would be 4. So h squared plus 4 squared equals 7.2 squared. I can do Pythagorean theorem to find my height. So this would be h squared plus 16 equals, all right, let's do 7.2 squared, and that's 51.84. Subtract the 16. And get 35.84. Square root to find h. And get 5.98665. If we round that to the nearest tenth, that's going to round to 6. All right. So if our height is 6, I'm just going to stick it, whoops, I didn't mean to write a 1 here, right there, and then calculate the volume. So 1/3, 886, 128. And this is in inches. And ice cream cone from Brewster's has been licked till the cone is just full of ice cream. All right, so we've got a cone here. And let's assume it's a cone and not one of those flat things. The density of the full cone is 5 grams per cubic centimeter. All right, so we've got density equals mass divided by volume. We know the density is 5. If the cone has a height of 15 and a diameter of 10, so that would be 5, then find the mass of the cone when it's full of ice cream. So what I need to do is find the volume of the cone and then use it in the density formula. That's what I'm realizing. And since they want me to solve for mass, that must mean that I should be able to solve for the volume first and then use that formula. Well, the volume of a cone is 1/3 pi r squared h, which is 1/3 pi 5 squared times 15. All right, and let's figure that out. So 1/3 pi 5 squared 15, 392.699. So that's going to go here. And if 5 equals m over 392.699, if I multiply by that 392 number, I will get the mass of the cone. 1963.5. And that would be in grams. And that, my friends, is it. So, volume of a pyramid, volume of a cone, same thing, 1/3 the area of the base times the height. If it's a cone, you can be more specific and say it's 1/3 pi r squared h. That is all. Have a glorious day.